All right. Good afternoon, or we're getting closer to good evening, everyone. Thank you for coming, and I will try to keep it interesting because I realize that I am the last person between you and the attendee party tonight, but buses don't leave until 6:45, so this is a good way to spend the time in between. My name is Mike Bishop, and I'm joined by my colleague Srini, and we're going to be talking about mobile broadband and connection management in Windows 8. So to begin with, what we plan to approach is how you can differentiate mobile broadband service, how you can enable cost-aware networking in Windows 8, and how you can simplify the experience using the mobile broadband class driver and device services. Now, how many of you saw Billy Anders' talk in the last session? Fair number of you. All right. So, when you were at his session, you would have seen that Windows 8 offers a simplified user experience, that Windows is smart about networks, and that Windows provides you a robust platform for differentiation. In this talk, we're going to dive a little bit deeper into what each of these looks like and how you can achieve them. Simplified user experience comes from using the mobile broadband class driver. As I saw on a live blog during the keynote, class driver means devices just work, and that's basically what we're going for. And the class driver enables extensibility using device services. Windows 8 is smart about networks, enabling cost-aware networking for apps and for the OS, and allowing the interaction with Wi-Fi hotspots that come as part of a mobile broadband service or standalone from a wireless ISP. And Windows 8 gives you a robust platform for differentiation, which you enable with a Metro-style mobile broadband app, with branding in the OS that shows up in the Windows Connection Manager, and by configuring Windows to work on the mobile network using device provisioning. So to start with the robust platform for differentiation, what does a differentiated platform look like? The differentiated experience consists of course, the mobile broadband service. That's what mobile operators already have. It's what they're great at and where they have the existing experience. But that service goes with a device. Now that device might be a dongle that is plugged into the user's personal PC. That might be a tablet or clamshell that the user purchased from the mobile operator. But either way, that device is running Windows 8, and that enables the third piece, the Metro-style mobile broadband app. And all these things are tied together using device metadata. That's what enables Windows to associate the service, the device, and the app. We'll be able to get deeper into device metadata with a talk tomorrow about building great mobile broadband apps, Metro style. And in that talk, they'll talk about the different pieces of device metadata and where those come from, how they get delivered to the PC. When you provide all those things, what gets enabled is that when users want to get connected, you'll be there. The mobile operator has the chance to interact with the user and to offer their service as an option when the user wants to get online. And to give an example of what that looks like in Windows 8, we're going to have Chris Jones from Vodafone come up and show us the app that they have built. And
thanks, Mike. So, as you saw in Billy's and other demonstrations before, we've actually worked with the team very closely to check some of their ideas, make sure it works from an operator point of view, how we can really use those sort of things. You know, we all live in a connected world. We want a great experience when that happens. So part of that is our ownership of the customer to enable that to happen. One of the things that we worked with the team very closely on was actually what are the real key things that customers need to know. You know, they need to know, you know, all about their account. They need to know about warnings and service notifications and whatever. And you know, with the tools you've been able to. Come on, come back in. bit smaller.
I'd like to screen off.
Okay. With the tools that you were able to put in, we were able to then create an application that then used all the applications elements. When we built the application, the gremlins are here.
Notification.
Yeah. So, unlimited. It's not starting. The gremlins are here.
Okay.
Shall we use our... It's not even running. Yeah.
Can we show the app one? Switch to this one?
Yep.
Okay.
Hopefully that one.
Yeah, that'll take a minute to show.
Okay. So that. It's on.
Well, in the meantime, so what you're able to see here is the Windows Connection Manager that allows the user to select what network they want to connect to. And you saw an example with the AT&T SIM that's in the embedded module of having the carrier's name, but also the carrier logo. So you have branding in as part of the operating system, and the network can be associated with the carrier's brand and brand imagery.
So let me talk you through the things that hopefully we'll be able to show when we flick back to the other machine. A few things we were talking about is the ability for the operator to give an account function. So be able to tell the customer about their different functions, about their balance, where they can top up. If it's a contract account, you wouldn't have the top-up functions. You'd have an online service or whatever. Notifications, so be able to display this back to the customer. We actually use the notification framework, and hopefully when this machine comes back, we can show you that. We've got help and support. You're not always connected. When you call up a customer care, you need somewhere to go. You need to give people guide as to what to do, how to contact you if you can't get connected. All those sort of things. The other area, which is very important for a mobile operator, is actually the extras, as you can see on the left here. So you can use the platform to then promote services based on the segment they're in, based on their current status in their plan, or some new services you're offering. And not only can that be done in the full tile, but actually in the tile down here on the start screen, you can use that to inform or to tell them about they're nearing the end of their account, or things like that. Okay, go back to that one. Okay. It's coming.
Given a moment for the projector to sync up. Okay.
Is it plugged in?
Okay, we may have to pass on the tablet for the moment. Okay.
Okay.
We'll just move on.
Yeah. So I mean, from an operator point of view, unfortunately, I couldn't show you all the bits. Some of the stuff that we've done is around notifications. So being able to inform your customer, but in that notification, it's able to be branded. You define the branding of that notification. How you then action on that. Does the click of that notification take you through to a relevant section of your application? Second area is really around out-of-band communication. We've implemented the USSD driver within there. So when you're not connected, you can still do account handling functions. You can also build services on that. There's two other areas that are optional within the inbox driver, and Srini will tell you a bit more about it. But SIM Toolkit and EAP-SIM. They're optional, but an operator like ourselves would make them mandatory. So it means that there's support for them in there and they can be used. You can create great services from that. EAP-SIM's starting to roll out more and more. You can create a great experience for those Wi-Fi networks that you use to actually seamlessly do it for the customer, using the SIM, using your security. So from that point of view, you know, what we're excited about is actually the connection management goes into the operating system. It's the best place for it to be. It is power managed properly. It's dealt with by the operating system properly. And it also lets developers understand that they're on a different type of connection. So that's all I've got to say on that side, Mike.
Okay. Thank you, Chris. So let's have a look at what you would have seen if we'd been able to walk all the way through that. What you were able to see was the carrier branding and the operating system. You saw in the Windows Connection Manager the network list, even though there was not any credit available on the SIM. You saw the Vodafone, which was roaming on AT&T's network, show up as a connectivity option. What happens when you click on that network? If the user has an account and it's active, they get online. If the user doesn't have an account, it leads into the Metro-style mobile broadband app, where you can provide a purchase or top-up experience. And once the account has been purchased, you can provision the profile settings that are needed on Windows to configure this PC for the plan that the user's just purchased. So let's think about that Metro-style mobile broadband app. It's got a number of advantages. To begin with, it has everything that a Metro-style app has to offer. It can be developed in your choice of programming languages, including HTML5 and JavaScript, but certainly not restricted to that. You can use XAML, C#, C++, VB, the list goes on. It gets distributed through the Windows Store, and it has access to the live tile to display information to the user. If you saw on the start screen, the Vodafone app scrolls through a couple different states showing the Vodafone branded racing car. And the advantage that it has over a standard Metro style app is the user doesn't have to go find it and download it. Because the mobile broadband app is a type of device app. That means when the device is connected, it's automatically downloaded and installed by Windows to go with that device. In this case, though, the device isn't the mobile broadband adapter. The device is the SIM. It's the subscriber ID. Now, that subscriber ID may be tied completely to the adapter in the case of, say, CDMA, or if it's a GSM-based provider, then there can be multiple SIMs that are swapped out through the same adapter. And we tie it to the subscriber ID. That also means using ranges of subscriber IDs, you can target apps to customers of the same carrier who have a different relationship with you. If you have an MZ range for business customers, you can provide them one. You can provide a separate app that is co-branded with an OEM. You can have another one that is strictly your postpaid service. And you can slice that up however is appropriate for a given mobile operator's network. So the purchasing experience is accessed the same way that you get online. As I said, if you click the Connect button to get online and the account's not active, it launches the app instead. And when the app is running, it has several different ways it can talk to the backend servers to perform that purchase. That connectivity can be a restricted mobile broadband network. You see in the Vodafone case, we tried to get online and it does connect, but you're in a captive portal. So you have a connectivity route to the back end if that's allowed through the captive portal. You can also perform the exchange using SMS or USSD because those don't require an IP connection As we saw in the keynote, that's a sideband that can be used even if you're not connected to the network. You just have to be registered on L2. Alternatively, you can use a separate internet connection and use an internet-facing service to provide that purchase. Now, if the app's not installed yet, there's also the option for a web-based purchase experience, where you can have a URL that the user is routed to when they attempt to connect. That requires some other form of connectivity, obviously. We can do the provisioning from there, and then once the user gets online, then we will download and automatically install the app. That's useful for a case where the user plugs in a dongle, they don't have any other form of connectivity, and they expect it to just start working. Once they have either the app or the web-based purchase, that enables the user to easily top up or buy a plan and get online quickly. Once you've got the plan purchased, then you need to inform Windows about that plan. And this is an XML file that you pass into Windows that packages up all the settings that are needed for connecting to a given mobile operator's network. Now, if you're familiar with Windows 7 and existing APIs, we've got mobile broadband profiles and Wi-Fi profiles that are both described as XML profiles. So those profiles are wrapped up in a larger XML file that can contain multiple mobile broadband profiles, many hotspots. And you can also include Whisper credentials for those hotspots. You can provide plan and data usage information about those networks so that Windows knows what the user is allowed on those networks so that Windows can make the right decisions. And you can update these at any time. Just to give you an example what it looks like, you have the carrier provisioning as the top element. Within that, you have an issuer and subscriber that tells us for which carrier and for which unique subscriber ID this file is targeted. After that, you have one or more mobile broadband profiles, or 0 or more actually, and 0 or more WLAN profiles. So these are hotspots that the user can transition to either to move data off of the mobile operator's network or to have no cost if it's uncapped. Using that information, that is what enables Windows 8 to be smart about networking. So now we're going to take a look and see some of the ways that Windows 8 changes its behavior based on the network it's connected to. Now, when I set up this PC, I was a little bit concerned about bill shock. That's the case where something's being downloaded in the background, you don't even expect that it's going to consume a lot of data, and you wind up getting massive overages that you didn't notice. So I turned off Windows Update because I didn't want to download anything gigantic. And you can see here, updates are available. That's a pretty large one. Now if I, actually let me check where I'm connected first. All right. So we're going to connect to the AT&T network. Previously, I wouldn't be able to download anything because I wasn't online. Now we're going to get connected, and we'll see that Windows Update warned me in the UI that I'm on a metered internet connection. So at that point, I decide maybe this is not the time to be doing it over mobile broadband. That sounds more like a job for hotel Wi-Fi. Now I'm curious, how many of you in your hotels get directly on the internet when you connect? Okay, not many. So you go through some kind of a captive portal first, right? Have to enter credentials, your room number, accept some terms of use. Well, what Windows 8 allows is for those hotspots that require authentication, we support the Whisper protocol so that you can provide that authentication as part of the connection, and Windows can store that and resubmit it the next time you can connect to that network. In the same way, you can get those credentials from the carrier and provide it to authenticate to that network. So we see, without going through a captive portal, I connected, was prompted for credentials, provided it, and now I'm online. If I come back to Windows Update, I'll see up to date. That's yes. All right. Let's quickly check for updates again and see if that's accurate. All right, there we go. So there are updates pending. So I can come back in here. Now I'm on the Wi-Fi, so I can start that download. So it's going to go through its processes of figuring out what packages it actually needs to download, and we'll wait for it to get a little bit into the download. So it's apparently not quite so fast that it can download 400 megs in the blink of an eye. All right. Uh-huh. Okay. Well, so what we would have seen there is that when I transition from Wi-Fi onto 3G, it would interrupt the transfer and ask me whether I want to continue or cancel that download once I'm on the costed network. So now I'm going to set it, let me disconnect from the Wi-Fi. So I've set it to automatically download, and we can come in here and see that on the mobile broadband network, we're not transferring any traffic, even though there are updates waiting to download. But when I go back onto Wi-Fi, and I can connect again, and it's got the saved credentials, so it authenticates me immediately, and I come over to wireless, and here you see that we're not completely idle in the background, that there is traffic going on. And I would expect Windows Update to be automatically downloading, but we will pass on that then. But Windows Update will change its download behavior based on the network that you're connected to. It will automatically download updates by default only when you're on an unrestricted network, like your hotel Wi-Fi. Once you've connected, it's paid for as part of your room cost, or you've already paid for it when you connect, and so you don't have a cap on how much you can download. That's a great time to download Office 2010 Service Pack 1, which is what we had pending there. When you're on your mobile broadband connection and you have a 250 meg plan, that's not a great time. And Windows Update is aware of that. So we saw authenticating and connecting to a Wi-Fi hotspot, and we saw Windows Update changing its UI and its behavior based on the network that you're connected to. So let's talk about the Wi-Fi hotspot to begin with. The mobile operator can configure Windows with a list of Wi-Fi hotspots. They can give us the preferences that they want between the hotspot and the mobile broadband. Now, if you have a network that's under significant load, you'll frequently want to use those hotspots to have a chance to offload traffic. And when the user's in range, you want them to use that network. On the other hand, if you're providing LTE service, where your 3G, or obviously 4G, is so much faster than the hotspot, then you would want to use the hotspots as less preferred than the mobile broadband because it's a fallback. If you're not in range, if you're inside a building that gets horrible reception, then you want to connect to that Starbucks Wi-Fi that's down the street. And Windows will automatically connect you to the most preferred network that's available. Windows will automatically disconnect the networks that are idle. So in Windows 7, the behavior was you would connect on each media type to the most preferred network that was available. But that meant that you could have a PC that was docked in your office, had an Ethernet connection on the dock, had a Wi-Fi connection to the corporate network, and had a mobile broadband connection to their carrier as well. In Windows 8, we prioritize those connections. And as you have one connection become available, we'll connect to it. New traffic flows over that connection. We let traffic die down on the old one, so we don't interrupt the transfers that might be going on, but we wait for them to complete. And once traffic has reached an acceptably low level, then we'll disconnect that interface. And we'll move smoothly between networks that way. Now, it's worth noting, even though the mobile operator can provide a preference order, the user is in control. The user is able to say, I want to connect to this network, even though it's less preferred. And there are restrictions that IT administrators can apply, such as, even if the user wants to, they shouldn't be on the corporate Ethernet and the mobile broadband network. Dual homing can be prohibited by group policy. When you're connecting to that Wi-Fi hotspot, we can authenticate using several of the common authentication mechanisms. We support Whisper 1 and 2. And for mobile operators, we also support ePSIM, ePKA, and ePKA Prime, so that we can use the SIM to authenticate to the Wi-Fi and do that handoff seamlessly. And in the case of Whisper, the mobile operator provides those credentials as part of the provisioning file. Now that we have multiple networks we can connect to, we can approach the way Windows should behave on each of those networks. In the provisioning file, the mobile operator provides plan information to Windows. So Windows can change its behavior based on that information. We saw Windows Update changing its UI and its behavior. This also affects the download broker that Metro-style apps can use to perform large downloads in the background. That can be set to only download over an unrestricted connection, or you can say the download is important enough to transfer even over a metered connection. And for apps that handle their own connectivity using sockets or HTTP requests, the plan information is provided to all apps, which means both Metro-style and desktop apps, so that they can adjust their own behavior to be appropriate to the network. So plan information consists of, first off, the network state. So we would want to know whether the user is over their limit, whether the network is congested. Say, for example, there's an extremely large conference talking about mobile broadband and handing out free devices with AT&T SIMs, and the network is getting somewhat congested. Or we can be roaming. Now, roaming is not something that's coming from the app. Roaming is controlled by the device. So mobile operators will need to work with the vendors of their mobile broadband adapters to make sure that the firmware is correctly reporting when they're in a roaming state and when they're actually on the operator's network or an affiliate that's not considered roaming. You can also tell Windows what the cost type is on this network. So you can say that it's unrestricted. Once you're connected, there is no cap on how much you use. You can say that it's fixed. There's a cap. The user can use up to that cap. And if they go over, there's some consequence. Or you can say that it's variable, that the user is going to be charged on a per byte or a per minute basis. So they should be very cautious in using that. You can tell us what the user's current data usage is, and you can tell us the limit that that's working against. You can give us the billing cycle, which lets us know when to reset that data usage number. Tell us whether there's an SMS plan, and other things that help hint the right behavior on a given network. Now, this information changes over time, so there are several different ways that you can use to provide the updated version of this information. From a Metro-style mobile broadband app, we have APIs that you can call to directly give us a new value for data usage, because that's changing almost constantly. Or you can tell us a new plan type, because as the user crosses a threshold, you might say, you've hit your limit, and we're going to throttle you, but there is no further limit. Or you've hit your limit, and now you're paying per byte, so you need to go to fixed, or to variable. Other changes are essentially a new plan. if the user went from a 2 gig cap to a 5 gig cap, then it's a new plan, give us a new provisioning file that fully describes that plan. Carriers also already have infrastructure for sending SMS and USSD alerts to tell users about the state of their usage. So if you've come close to your cap, you may have gotten an SMS message that says you're at 80%, you're at 95%. And those messages can be used to update Windows knowledge of the current usage. That can update anything except the billing cycle or the Wi-Fi profiles. And Windows will parse those incoming messages and update the mobile broadband profile appropriately. So to give some examples, if you want to update it from the app, we have the update cost and update usage APIs. If you're providing it in the provisioning file, then within either a mobile broadband or a Wi-Fi profile, you can include the new cost element to describe what the user's usage is, when that usage was current, and the cap, and all of that information is part of the XML schema that goes into the provisioning file. Now, if you want Windows to parse the notifications for you, that's obviously not something that we can magically know the format of the messages. So in the provisioning file, you describe them to us. We have to know who the message is coming from. So we get the sender and whether or not to expect it to be a class 0 SMS. You tell us what the message looks like and what the fields are so that we can parse it. So here we see the message is going to be something that contains the string your current usage is, and then five fields telling us usage, cap, and what the timestamp was on that usage. Then you have to tell us, for each of those fields, how do we read it? What units are you going to use and the strings to correspond to that, and which field corresponds to which value that we need to fill in. So, we've talked about how you can use a robust platform for differentiation, and we've talked about how you can enable Windows 8 to be smart on networks. At this point, I'm going to hand off to Srini. We can talk about the simplified user experience from using the mobile broadband class driver.
Thank you, Mike.
There you go.
Thank you. My name is Srini Malayala. I'm a program manager with Windows Wireless team. Before I start this part of the session, I have a quick question to you, and I promise this is the last question for the entire day. How many of you had mobile broadband solutions in Windows 7? Just a quick question. Wow, that's very interesting. Good, that was the first step for us to transform into a consistent user experience. Now, given the full packed room over here, I can promise you that we are taking it to the next level, and you are at the right time and at the right place where the opportunity is at its best. Throughout the day today and tomorrow, you are going to hear a lot of our investments specifically focused on mobile broadband. There are a whole lot. We couldn't actually fit them into number of sessions because we actually exceeded the limits basically. So what you have seen so far, what you are going to see tomorrow is going to be a limited scratching the surface kind of stuff. One of the major investment that we are making in Windows 8, which takes us to the next level of the transformation, is to simplify the user experience with the introduction of mobile broadband class driver. Now, with all the demos, some of the demos, giving us a little bit of trouble, I start this with the demo. Hopefully, let's see how this goes. So what I'm going to demonstrate right now is the class driver over embedded module solution. I have a Windows 7 laptop. This is fairly old for this current standards, and it had a WWAN or a mobile broadband embedded module device, something like this. It's kind of a full-sized mini PCI card, and what we have done is that we have taken this laptop for the purposes of the demo. I have put in the build, the Windows 8. And what we have done is that we have asked our co-engineering partner at Ericsson to update this module with an early version of the class driver compliant firmware. Thank you, Ericsson. You have built us this, and I have put that in this laptop. What we are going to say is, let me switch the view into this laptop. Let's see. Okay, that's good. So now I'm into my account. Let's see. Let's go into the desktop. I just want to show you that there are few devices, couple of wireless devices. There's a Wi-Fi device. Here is the device that we are going to talk about, mobile broadband, Ericsson mobile broadband device. And on the left-hand side, you could see the device manager showing the H5321GW device. And I'm going to go launch properties and then go select drivers, and you can see the WMB class.sys, which is basically Microsoft developed mobile broadband class drivers. This to just show you that this device is right now running on an early version of mobile broadband class driver. Now what I'm going to do is that let's close this, we are good, and then I'm going to go to the Windows Connection Manager and then go settings. Let me keep my fingers crossed. I'm going to disconnect the hotel Wi-Fi, and I'm sure that's going to work. And oh, wow, this is already connected. Right now it isn't connected. What I'm going to do is that just to make sure that it is running on the class driver, we just saw the class driver, so I'm going to disconnect and then go back to the Bing to ensure that there's absolutely no connectivity. Right now there's no connectivity. Now let's go back, launch the Windows Connection Manager, and then we'll go to the Windows Connection Manager UI. What you're seeing here is the AT&T network, because I have a AT&T SIM on this laptop, which is embedded module solution. And you could also see this branding that was provisioned through the device metadata from AT&T. So now we have this network showing up, and then I'm going to click, and then you could also see that there's an estimated usage. That's the local data usage counter, and at some point in time it also gets synchronized from the mobile operator updates. Now I'm going to do the adventurous act over here. Let me cross my fingers, keep my fingers crossed, say connect, and then let's see. We have 1, 2, 3, 4, 5. There we go. It's been connected, and just to make sure that are we doing the right thing, I'm going to go back and then refresh this Internet Explorer. I have the bing.com there we go. So we got connected in less than 7 seconds. That's really awesome with the class driver. Thanks a lot. And again, thank you to our co-engineering partner from Ericsson. And what I just now demonstrated is Ericsson's H5321G module. It's actually half size as well as full size. If you folks are interested in, Ericsson has set up their booth at the Expo Hall, booth 39. Feel free to go and talk to them. More information with them. And what I'm now going to do is that disconnect again, and then let's do this adventurous act one more time. So, well, not the disconnect part. I'm pretty sure the disconnect will work. So let's do this. Disconnect. Alrighty. Now, earlier to this session, some of you might have been to Howard and Billy's session about connecting to mobile broadband and Wi-Fi devices. How Billy was enacting as Jenny. That was our favorite character. That's the scenario description that we use. Jenny goes to London and then gets down to the airport, and then our friends at Vodafone sells this really inexpensive $20 or $30 dongle. And let's assume this is the dongle, and the dongle that I'm holding right now in my hand, this is powered by Qualcomm's Gobi chipset. And again, our co-engineering partner, Qualcomm, on a special request, they have updated this device with class driver compliant firmware. Now, what I'm going to do is that take one level further down and then go do an insertion of this device in front of you folks, and then let's see what happens. Now I have inserted here while it is, let's go behind the scene and see what happens. Okay, so you could see that the Qualcomm device showing up in the device manager. It is going to take some time to come up in the network connections view while it is doing the background. There we go. It's absolutely, it has detected, the class driver detected the existence of a dongle, which is basically a compliant to the class driver firmware. And now what I'm going to do is that go to the connection manager and then see what is it showing up. Well, we have actually, you could see actually two dongles, I'm sorry, we could see two modules. One is basically the embedded module, and then the other one is basically the Qualcomm one. So just for the purposes of simplicity, I'm using my hardware switch in this laptop to switch off, and then you could see that, well, the embedded module switched off. And then you could also see that since we are enacting Jenny over here, it's actually a Vodafone SIM. It's roaming on AT&T network, so you are seeing the roaming. And I'm going to leave it at this point in time because the rest of the things are same. And again, thank you to our partner Qualcomm, co-engineering partner Qualcomm. And if you have more questions on Gobi's compliance to the class driver, feel free to drop by at the expo hall. Qualcomm is at, I think, booth number 6 in the platform partners zone. And what I also have here is a sample of a Qualcomm Gobi powered full-size Sierra Wireless MC7700 device, and this is also can be updated with the Gobi firmware, which is compliant to the class driver. So with that, let me quickly go back to our presentation. Well, that was not hard. So why did we do class driver? Of course, the easy part is basically that no software install required. I was showing you that I took a dongle and then I inserted it into the laptop, and you were seeing that the inbox class driver kicked in, and then it started running, loading, everything was fine. And I think it was pretty seamless. Is that right? It was like less than 5 seconds or so. Just for a test, before starting this demo, a week back, I took one of the dongles that was in the market, and I tried to do the same experiment to see what experience that I get, and it was really, really interesting. It took me 15 minutes to set up the dongle with 2 reboots, and here we are, ladies and gentlemen. We were able to see this in less than under 10 seconds, I would say, and you have the device up and running. So with all the investments that we are making in Windows 8, covering with the Windows Connection Manager, Windows Connection Manager UI, and the metadata, a whole lot of metadata. Mike was talking about the device metadata. There's an APN database. So that's one of the reasons when I clicked on the connect, you are able to see that it just gets connected. It's not asking you APN username and password. It's all there in Windows. So with all the investments that we have made, there's no reason for any additional software that needs to get installed. And so that makes it simplifies the user experience. And of course, while we were focusing totally on the user experience, when we talked to the mobile operators, what we later realized is that a class driver simplifies the device certification for the mobile operator. Think about just one driver that covers a whole gamut of devices. That's really awesome because now it minimizes the number of recertifications that you need to go through. It's pretty simple. With Windows 8, you have additional platform, we have ARM. Now we look into, there's a x86 32-bit, there's a 64-bit drivers, and there's going to be ARM. And take that, combine it with a whole lot of device manufacturers, and for each devices there are going to be a whole lot of drivers and driver revision. Now we get the big picture. There's going to be a whole lot of driver recertification that needs to happen. And with the introduction of class driver, you don't need to go through all those kind of stuff. So it really simplifies the device certification. And of course, right from the beginning of starting this class driver program, we have been very closely associated, collaborating, and co-engineering with all of our device ecosystem partners to bring or to increase the compatibility. I'm going to talk about it in the next 2 slides over a range of devices and device form factors. Not only that, a single driver allows us all in the ecosystem to focus on not only on various devices, but that gives an opportunity to Microsoft to also focus on this driver to be tested over a various of scenarios in Windows 8 specifically. That results in increased reliability over various scenarios. And with a single driver being certified over various mobile networks, the supportability of the various network technologies is going to increase over a period of time. So now that we talked about the benefits of the class driver, I want to move over into the compatibility part. So what does the mobile broadband class driver support? It supports various ranges of USB form factors, starting all the way from the mini PCI, the embedded module that I was demoing earlier, that uses USB. And for those of you who are very specific about the tablets where the Z factor is of concern, you could use the class driver on a surface mounted solutions like high-speed interconnect chipset, like for example HSIC. And of course, I did demo this with a dongle. Good, it didn't crash. I have seen multiple times when you remove the dongle, it just crashes the system. So there's a dongle, and then we support the dongle as well. And of course, in the interest of making this driver as widely compatible as possible, we are contributing to the standardization of this specification in the Network Control Model 2.0. This is a device working group within the USB IF standards. So we are contributing along with a whole lot of our co-engineering partners. Now that brings us to the question about the network support. What level of network technologies that are being supported? In Windows 7, we started off with GSM as well as CDMA, data packet network services. The Windows 7 supported both, and the class driver in Windows 8, we are ensuring that the GSM, which technically the 3GPP based packet data network services, all the way up to the long-term evolution, which is the 4G. We are supporting all the way up to the 4G, and we are also supporting the CDMA-based networks. And not only that, with keeping in alignment with all the business changes with the mobile operator world, we are supporting the dual mode networks, which offers where basically the networks started supporting with the CDMA, and over a period of time for 4G, operators like Verizon adopting the LTE. So we are supporting those networks as well. So that brings us the wide range of compatibility across devices and the network technologies. So quickly, as I was mentioning earlier, the focus right from the beginning of the mobile broadband class driver program has been on collaborating with our partners. And while doing so, when we reached out to our mobile operators and the device ecosystem partners, one of the things that we learned early in the program is, while doing the class driver, this space, the mobile broadband, is still at its nascent stage, and there's a lot of room for innovation, and there's a lot of opportunities that the mobile operators and the device ecosystem is looking for. And then the biggest ask is that make it extensible. And so we are making the mobile broadband class driver as extensible through something called device services extensibility. It enables the partners to implement additional features as a logical device service. That's what we call a logical device service in the firmware. For example, let's take that if you are a device manufacturer and if you want to provide new functionality, for example, if you want to provide the consumers with access to their context in the SIM, you can implement that as a phone book functionality as a device service. Earlier, while giving the demo, Chris of Vodafone was mentioning about the SIM toolkit. There are a number of operators who take advantage of the SIM toolkit functionality, and you can provide SIM toolkit as a device service extensibility functionality. And of course, the possibilities are endless in our opinion. You can do firmware update, you can do assisted GPS, I can just list a whole lot of things, so on and so forth. All we are doing is that we are providing you with a set of easy to use APIs to interface with the device services. For example, we are providing you, as enumerate, these are basic APIs, the enumeration of the different device services, query the device service states, send some commands, register for notifications. So we are making it as easy as possible, and this is a huge improvement over Windows 7, where in the Windows 7 we just provided a mobile broadband vendor specific functionality where it's just opaque pass through, but then now there is a level of discoverability. You can query, you can register for notification, and a whole bunch of stuff. So before closing this off, quickly let me walk you through this device services architecture. So here you have the mobile broadband device, and the boxes, the green boxes inside the device, they are the standard services that we have modeled. For example, the IP internet connectivity is basically modeled here as a connectivity service, and there's a texting, which is basically the short message services, and we have the PIN. There's a specific reason I did not talk about USSD. That's because we have the connectivity SMS PIN. All of them were available in Windows 7 and modeled as is. And in Windows 8, we are adding the USSD, and the class driver supports USSD as a functionality. So all this functionality are standard functionalities. And what we are doing is that these standard functionalities are basically on the top managed by the WN service and the mobile broadband class driver, and the WN service provides the mobile broadband API on the top side, top edge, where it's the same mobile broadband API that was available in Windows 7 for you is available in Windows 8. And with the introduction of Metro style apps, we are providing a Metro style mobile broadband APIs for the usage for the mobile broadband, Metro style mobile broadband app. Now, moving on, the device and the device makers can implement those device services, the new functionality or the new features, as set of device services. Here they are represented as 1, 2, and n, and you can see that it combines the flexibility of Windows 7, where it's kind of a pass-through once you establish the communication from the device service through the device services API to the device services through any of the 4 APIs that I was mentioning earlier. And so the Metro style mobile broadband app would use the device services API to go and communicate with the device services. So what this offers to all of us, to our customers or the consumers, with the standard services handled by the mobile broadband class driver, it gives a robust platform, compatibility, reliability, and supportability. While doing so, with the introduction of the device services, a robust platform with a differentiation possibility, which brings me to the beginning of this session, where Mike started off with Windows 8 enabling a robust platform with differentiation. Now, that kind of brings us to the end of this session, and a quick recap. So Windows 8 provides a simplified user experience with the introduction of mobile broadband class driver, and of course the device services makes it easy for you to innovate without replacing the class driver. You can start building functionalities on the top. And of course, earlier in this session, Mike was talking about through the device metadata provisioning, a mobile operator can light up Windows and make the Windows 8 cost aware, making it to be more smart about the networks. And he was also demoing the Windows Update. And of course, the Wi-Fi hotspots, it makes it the provisioning with the metadata provisioning helps us to provide a seamless authentication into the Wi-Fi hotspots. And of course, all the other investment that we talked about in the throughout the day, specifically the Metro style mobile broadband app, and the branding I was showing you in the Windows Connection Manager, and the device provisioning, Along with the device services extensibility, it provides you with the robust platform for differentiation. So thank you all for coming to this session. And we have, as I said earlier, there are lots and lots of investments on mobile broadband and focus on mobile broadband. So you might be very much interested in a topic that's coming up tomorrow, right here in the same aisle, room numbers 1 and 2, building great metro-style apps for mobile broadband devices. You might be interested in that. And of course, those of you who are doing the Wi-Fi as well, you might be interested in the understanding Wi-Fi networking in Windows 8. With that, I leave the floor open for any questions that you might be having. Thank you.
Just put it back in the rated section.
Put it back.
So I had a couple of questions. So the first one is there's a lot of customers that have older USB dongles that support Windows 7 mobile broadband. Will those just work in Windows 8?
Yes, one of the biggest investment that all of you might be already aware of in Windows 8 and in line with all the other Windows that we have released so far, we are focusing highly on the device compatibility and the application compatibility. So all the investments that you have made, all the investments that we have made in the ecosystem for our end user, that benefit we are ensuring that they are not broken, they are carried over further in Windows 8. So all the investments that you have made, feel free, it's all safe, it will continue to work. Have a great party in the evening.
Okay, great. And then the second question is, have you thought about the scenario of a mobile hotspot? So this is where you're connecting to the hotspot via Wi-Fi. Mm-hmm. So you still have the need to monitor usage and those different things, but it's not going to use your USB class driver and all of that stuff. So I was just curious whether you've thought
Absolutely.
of that and how that might work here.
Sure. Mike will be able to answer that one.
Okay,
Yeah.
Great. Thank you.
So the simplest way to look at that, as far as Windows is concerned, that will be a Wi-Fi network. So by default, unless we hear otherwise from the carrier or from the user, we assume Wi-Fi is probably unrestricted and 3G is probably capped. The carrier can tell us otherwise with a provisioning file, and what's useful for a portable hotspot, you can come here and choose reduce data usage.
Could we,
Oh,
the deck.
sorry, wrong source.
Okay.
Okay. You can come in the connection manager, select the network you want, and say reduce data usage. And that sets that Wi-Fi network to behave as if it's capped, and you'll get the basic adjustment in behavior. For things beyond that, we have investigated, but at least in the developer preview, there is not support for that. So this is the way you adjust it for now.
Did you say in the provisioning file, though, if you had a certain device that was like that, and it had a SSID that was kind of standard, and then it had maybe a couple of digits after the end, that you could put it in that regular expression and be able to determine?
So there's no regular expression support. So the question was, could the app tell Windows that a particular SSID was costed for a portable hotspot?
Via the provisioning?
Via the provisioning file, yes, you can, but that requires the app to know the exact SSID. There's not a regular expression for the Wi-Fi hotspot itself.
What is the improvement in connection times for Windows, for the mobile broadband network after resume, and do you expect the NICs to maintain connection in S3 to S0 when you resume to improve connection times?
Okay, so the S3 to S0 transitions, normally what we do is that we disconnect it when it went from S3 to S0, and on the way back up, when the system resumes from S3 to S0, we issue a command for getting connected again. So we manage that from the Windows 8 perspective, Windows perspective. Yep.
So what is the typical connection times for Windows 8? Because typically, if you don't maintain it, the connection times are more higher. So
So it depends on the availability, various number of factors that you might be already aware of. If the device has been already there, registered to the same PLM and so on and so forth, it is pretty quick. So otherwise, it's going to take some time to get the scan list updated, PLM list updated. So it's kind of little bit varying at this point in time. So we are hoping that at some point in time, this gets stabilized. And most of this are in the device and the 3GPP protocol. So that's where we are at this point in time.
And if you have a device that supports connected standby, you stayed connected to that network even though the device was off.
But about this question, when the device connects on the Wi-Fi coverage, the mobile broadband is connected,
Mm-hmm.
and the PDP is not disconnected. And for example, for my country, it's important because we have a lot of offer on time, and it's important to disconnect the PDP contact when using the Wi-Fi coverage.
So the question was about disconnecting from the PDP context when you're in range of Wi-Fi. So we remain registered on the network, but we do tear down the PDP context when we're transitioning off of mobile broadband. Yeah, so a disconnect for Windows means we tear down the PDP context. It does not unregister from the network. And
yes.
I think this is going to have to be our last question because we're at the end of the session.
Through the provisioning file, can you control things like proxy or the ability to initiate a VPN or any of those things?
Proxy settings are not in there. For a VPN, the user would initiate that or the service would initiate that when it sees a network change.
Okay.
So that's not part of the provisioning file, no.
It's not. Okay.
Thank you all for coming, and we will be around for several more minutes after this session if you have further questions.
Thank you.